Hi, AK. Can you hear me okay?
Yeah, it's clear now. Thank you.
Thanks, AK. Apologies for that, everyone. So as I was saying, my name is Riley, and I assist in coordinating our various free webinars that we hold every month that are posted on our events page on our website. I'm currently streaming in from our beautiful campus here in Perth, Western Australia. In today's session, we'll be discussing transitioning to digital manufacturing with Industry 4 technologies. So that is our technical topic webinar for today. Our presenter is Dr. Akhlaqur Rahman, and he is our course coordinator and lecturer for industrial automation engineering. I'd just like to mention we like to keep these webinars as interactive as possible, so please use the chat box if you have any questions or you'd like to share anything during the session. I'll be active in the chat box if you have any non-academic questions, and I'll be able to answer them for you. And if we have some time at the end, we'll also hold a Q&A session where you can ask any questions and we'll try to answer for you for them while we're live. So these webinars are recorded and you will receive a copy of the PDF slides and the link to the recording in an email within the next 3 business days. I'll just quickly run through the agenda. So AK will introduce himself and we'll give a brief overview of EIT, and we'll go through the objectives for the webinar, an introduction to Industry 4.0 and digital manufacturing with Industry 4 technologies and some applied cases. And as I said, we'll go through, we'll try and hold a quick Q&A session at the end. So without any further questions, we'll just hand over now to Dr. AK. So thank you. If you'd just like to give a brief introduction of yourself and introduce yourself to everyone, that would be great. Thank you, AK.
Thank you, Riley. Can you hear me clearly?
Yes, I can hear you great. Thanks, AK.
Perfect. Thank you. So welcome everyone. All 190, 92. It's okay. It's increasing. Let's say almost 200 of you for attending the presentation webinar today. I'll just give a quick intro of myself before we go into the technical topic. So my name is Dr. Akhlaqur Rahman. Everyone calls me Dr. AK, easy to remember. So I am basically with EIT for almost 2 years, Engineering Institute of Technology. And with the engineering field, I have been for almost 10 years since after my graduation. I am specializing in electrical engineering and more recently with industrial automation courses at EIT. I'm a member of Engineers Australia and recently I became a senior member of IEEE. I'm also the secretary for IEEE Young Professionals Executive Committee for the Victoria section, where my role is to arrange events similar to this to encourage more young engineers to prosper and do networking and prosper in their field. From an academic point of view, my PhD was on cloud robotics, and that was related to Industry 4.0. So I've been in this area for a few years now, and more recently, as you can see here, my area of interest is more on industrial IoT, virtual manufacturing systems, a little bit of cybersecurity as well, but we're just starting on that area. But yeah, so that's me. Hopefully you'll enjoy the webinar today. Thank you, Riley.
Thanks, Dr. AK. So just a brief introduction to EIT. So we are an engineering specialist. We only deliver engineering courses, and we have a range of programs such as short professional development courses, as well as accredited courses, vocational, as well as higher education. And now more recently, we've also offered a Doctor of Engineering. Our programs are updated regularly to stay up to date with industry standards and make sure that you receive the highest quality qualification that will be valuable to your career. We also have internationally accredited programs. Some of our programs are accredited with Engineers Australia, so you can have a look at those, and all of our programs are accredited in Australia through TEXA, the governing authority. We also have industry experienced lecturers, so not only are our lecturers involved in academia, but they also have hands-on experience out in the industry, which makes them able to deliver practical courses, and we're very focused on practical learning at EIT. Our unique delivery model includes our international pool of expert lecturers, as well as our learning support officers, who are dedicated points of contact for our students throughout their courses, and also our state-of-the-art technologies, such as our hands-on workshops, remote labs, and simulation software that you can use in some of our courses. I'll hand back over to you, AK. Thank you.
Thank you so much, Riley. So we can probably begin, and thanks for the wonderful introduction of EIT as well. So we'll probably discuss about it at the end as well a little bit. But going back to the main presentation of the topic today, transitioning to digital manufacturing with Industry 4.0 technologies. So mainly, if we have to divide our webinar into two parts today, it will mainly be two things. One is Industry 4.0. So what is Industry 4.0? A very buzzword nowadays. Everyone talks about the Industrial Revolution, what Industry 4.0 is. So we'll do an introduction to that. And later on, we'll talk about digital manufacturing. So what digital manufacturing is, what is the scope of digital manufacturing, and how Industry 4.0 basically plays a role in digital manufacturing. Okay, so starting with Industry 4.0 and a brief introduction to Industry 4.0. So as we mentioned at the beginning, this is an interactive session. So let's probably put that to a test a little bit. Can anyone just in the chat box write down what each of these machines are, or any of them basically, if you can just think about it, what these machines could be? Anyone? Yes, yes, yes. I can see everyone writing. Yes, I can see almost all of you are correct in what you're mentioning. So this, if I just do a quick explanation, the one on the left is basically a grain grinding stone, or a grain grinding. So this is the oldest form of using stones to, well, grind. Then over time, there was a technology called a water mill. So where water was the driving force for and that was again used for operations such as grinding. Then came electric mills, where again you had electricity. With the advent of electricity, those were used as part of grinding operation. And then with more automation technologies came recent options where you have automatic grinding machines and mills. So I can see almost all of you got it correct. So well done, off to a great start so far. So the main idea of this slide is to present that fundamental changes in the way products are being produced, delivered, and consumed. Almost everything that you'll see around you, or maybe something that you're using, that has evolved over time. And how has that happened? That has happened with the new technology that has come about, and how that technology took over and found a new way, or maybe let's say a more efficient and easier way of utilizing a present technology, and people over time basically transition to that. Similar with the grinding machine, you started with a grinding stone, and then water mills, then basically machinization, then you had electric mills, and now you have automated machines. Let's do another example. For example, in the 1800s to 1900s, whenever people used to do, let's say, ice, right? What they would do is harvest and harvest ice, and they would ship it to a location where they can use it for a later use. In the early 1900s, they found a way of creating that in the factories. After a few decades, they found a way of producing it at your own home, much more convenient. Now you have smart fridges that can check the water level in your fridge, and if the ice is not there, they can you can say prepare a setting, and or maybe you can just give a voice command, and this will be activated. So over time, again, technology is progressing. But the main thing there is how is it progressing and why is it progressing? It's progressing to provide an easier method of living. And also the reason it's progressing is because you have more technologies, new advancements coming that's driving these changes. So ultimately, the summary here is whether it's let's say a simple wheel that started with the Stone Age to the Middle Age to the current tires, or if it's basically lighting, where it started with simple candles to current lights or more smarter lights that are currently being used, bulbs to let's say smart lights that they are using now. Everything is evolving over time. So every technology that you're using that has actually been impacted by the revolution of the industry that takes place. Just going on the same trend, let's see a couple of new technologies that are being used in the let's say last 10 years or a decade, and how that is impacting the manufacturing business, because today's presentation is all about manufacturing. So let's think about Amazon or their warehouses, right? If you see this graph, or this chart, basically, this presents an increase in numbers of robots that are working in Amazon. So this was from the period of 2013 to 2016, from a few hundred to almost 50,000. And again, that was almost 5 years ago. Alone from 2019 to 2021, in that 2 years alone, there was an increase of 75% use in robots. So there will be hundreds and thousands of robots that are currently probably being used or being working at an Amazon warehouse. So again, a new technology that is being used in work, in this case, manufacturing. So with the robots that we're mentioning, one of the key parts of this new automation trend, you'll see that the robot sales has also increased. There is an increase in robot sales. And you'll see some countries are already miles ahead, like for 10,000 manufacturing employees, countries like South Africa, Korea, Singapore, Japan are way ahead in how many robots they are manufacturing. And you can see the metal industry, electronics, automotive, all related to manufacturing are industries that are leading the charge. So the reason we're giving all these examples is just to set this idea in your head of how technology is evolving and what is the current context at which we are talking about. It's no longer about humans, turning on a machine and turning off a machine just to, for a manufacturing process. Today's factories are much smarter. They are smart factories, whether it's machines that can operate autonomously, humans just monitoring them from a higher level, or whether it's the design process that's happening, or whether it's the warehouse part where packaging is done, or they are all connected in a smart factory, and their autonomous or rather automation has being placed through different technologies in each of these components or each of this part of the manufacturing industry. And humans, rather than working on the floor level, which there still are, but again, that's why we use the term transitioning, and more transitioning towards a higher level, where the idea would be, instead of robots being controlled by humans, it's actually robots working among themselves, and humans are monitoring and operating them from a higher level and making more higher level decisions. That's where the industry is basically transitioning towards. So everything that I said in the last 10 slides, if I had to summarize, that where we are currently at is at the peak of Industry 4.0. we are in a scenario where machines want to communicate with each other, and machines can operate among themselves, they make decisions, and humans can operate from a higher level. But how did this industry came about, or this revolution came about? For that, we need this short visit to the history of Industry 4.0. So if we start from the 18th century onwards, you'll see that the first revolution of industry came with mechanization. And what that means is with technologies such as water power or steam power, they could run they could provide mechanical output that could run certain operations. So that's what they mean by mechanization. Then came with the advent of electricity, they could run batch operations, and in an assembly line, machines, in a conveyor belt, machines operating one after another. That's what that was again run by electricity. Let's say about a few decades ago, with the more advantage of computer and automation, humans could operate machines and the machines could do the work. And now you have come to the age of cyber physical system, where machines can compute with each other, and they're taking data from the environment, computing them in a different location, and then doing the work themselves. In order to explain this a little bit better, I'm just going to stop the sharing and just share with you guys a couple of quick animation video. And the idea of the animation is just to show you guys some presentation slides that might help you explain. Can you quickly mention in the chat box if you can see the PowerPoint file here?
Yeah, all good.
Thank you. Okay, we'll just do a quick intro here. So have a look. So everything that I was telling you about, thank you for the responses. So everything I was telling you about, so from Industry 1.0, right, using steam power or water power. So as you can see, mechanization in effect. So using that power to convert it into mechanical energy that is basically being used as part of an operation. That was Industry 1.0. Then came Industry 2.0. Again, you can see using electricity, you had the option of doing a batch assembly or assembly line operation rather, where you can do mass customization. So in a group, you can change the operation and get a group of, let's say, outputs that are in a same pattern. So this was again all due to electricity. Industry 3.0 was more about computer and electronics technologies arriving, and you can have humans operating these machines on demand to decrease their labor. And now with Industry 4.0, it's about computers, robots or different machines operating among themselves, and humans are actually monitoring from a higher level to see if there is any changes that need to be made. So the operation that humans are doing now are at a much higher level. That's the goal of Industry 4.0. Now, the main theme of this presentation today is, of course, to discuss more about sorry, I'll just quickly share the file again. Yeah, to discuss more about Industry 4.0, but rather from a manufacturing perspective. So going back to this slide, hopefully that slide was useful for you guys to understand what the different industrial revolution means. So talking about the current industrial revolution, which is about cyber physical systems. So again, there are two parts to it, cyber and physical systems. So what does that mean, and how does Industry 4.0 relate to cyber physical systems? The simple example I can do is, and let me do a very bad drawing of a robot, more looks like a human, but imagine if this robot has different sensors embedded in them, right? It can be a temperature sensor, it can be a motion sensor, it can be a collision sensor, or well, the motion sensor can detect that. But the idea is these sensors are collecting data from the physical environment, right? So you have sensors embedded in robots that are collecting data. based on those data, let's say if the temperature is too low, you need to increase the temperature or something like that. So the robot is trained to do that. So based on that data, computation will be running. Okay, so based on the communication, computation will be running, let's say in a cloud or in the robot system. And that based on that, you have actuators like robotic arms that can make the changes to the operation. So that's what the cyber physical system is. So the cyber part is the data you are collecting and the computation you are receiving. And based on that, the physical part is the actuation. So the actual robotic arm, for example, using it to control a part of the operation. So this is where Industry 4.0 is. You are collecting the data from the cyber part and presenting and controlling the operation through your physical actuation nodes. Again, just to reiterate that point, in an industry point of view, for another manufacturing industry point of view, it will be the same idea. So the physical world in a manufacturing industry would be all these machines that you're using. It could include the autonomous robots as well that are building things, the assembly line processes that are there. But the operation and the decision making of that could be happening somewhere else, in a cloud, for example. And if it's in a cloud, you can actually have data storage, data being stored there. You can use machine learning or artificial intelligence techniques to, let's say, predict some issues that might happen with the operation. Let's say if a parameter needs to be changed or something like that. So this communication between the physical world and the cyber world, and based on that, the actuation being relayed back to the physical world, that's the main theme of cyber physical system, and that's what Industry 4.0 is all about. I hope you guys have some idea about what Industry 4.0 is. Can I just get a quick comment, maybe like a thumbs up if you understand so far a little bit what we are trying to talk about? Thumbs up or a yes? Oh, wonderful. Very receptive, very interactive. Love it. Brilliant. Thank you. So let's move on to the next topic. Of course, we don't have too much time, so we do need to cover a few things. What are the benefits of Industry 4.0? We'll discuss a little bit more from the point of view of manufacturing a bit later on, so we won't go too much here. But the main benefit of Industry 4.0 operation is it's cost saving, and it is a better visibility of manufacturing process. So what happens now is the whole operation is all connected, and you can see it from a higher level. And when I mean higher level, I mean every part. It's not just the design process, it's actually the production process, it's the, let's say, logistics afterwards, where you have the warehouse distribution process. Everything is monitored from a higher level, and you can see more easily where each of this communication or each of this work is happening and how you can change it. Okay, so that's the main benefit of Industry 4.0. And because you have a better visibility, you can have a better control of the operation, you can change parameters, you can change design processes, and that basically saves you a lot of cost because the process is a lot more optimized. So what are these components of Industry 4.0 that makes it all happen? I'm just going to mention the names here because later on what I'll do is explain all of them from a manufacturing point of view. But the first one I already mentioned, cloud computing. So using a cloud technology, or where everything is stored and you can get support for computational. You have big data and IoT. So IoT means all devices are communicating with each other and they can talk among themselves and make decisions. You also have things like big data. So a huge volume of data that is being passed on from the sensors, because the whole theme of cyber physical system is the sensors are collecting data. So imagine hundreds of robots operating in an operation. So hundreds of robots operating in an operation, and they're collecting data from the sensors. Where does that data go? They go to the cloud, where all these data are mined. So data mining is done, the data is processed, and then data analytics is used. So let's say using artificial intelligence or machine learning technique, you can analyze the data, and based on that, let's say this huge volume of data, you can make certain decisions. For example, if you get data for a machine for, let's say, 2-3 days at a particular time, based on that you can get an idea that the machine is not performing as per its requirement, so there might be some problem. So you run another tool, you may, let's say, run another machine learning, or you can do another operation to see like a diagnostic, as they say. So like, what are the function that is not working up to the mark, and based on that the machine learning can tell you an idea that if this operation runs at its current speed, the machines might not work after 5 days. So you can actually predict where a certain operation might fail, and you can make changes. You have technologies such as augmented reality or virtual reality, where you actually create a virtual representation of the physical system. So any changes you can see on the virtual world, and that can first be checked there, and then you can implement it in the physical system. You have technologies such as 3D printing. So with 3D printing now, you can make small prototypes, especially in the design processes, about, let's say you want to make a slight tweak to one of the products. You can do with using 3D printing, you can do that early on in the process, and based on that, you can make changes or make decision whether the changes are suitable or not. Again, giving you more control over the operation. Of course, you get an idea about what the robots will be doing. Cybersecurity is also a very critical issue. So the issue with the cybersecurity is, and again, this is more from a point of view of Industry 4.0, the whole idea with Industry 4.0 is everything will be communicating with each other. So let's say 2 cars are communicating with each other, 2 machines are communicating with each other, 2 devices are communicating with each other. What that means is that data is now not stored within I just saw a comment about digital twin. We'll explain about the digital twin as well a little bit later on. Anyway, so the data is not stored within the machines anymore. The data is being sent to the cloud. So what that means is now all these data are no longer specific to that machine. And because the data is stored in a third party or a separate cloud, even if it's a private cloud, if that gets breached, that means the data is all in risk. So data security is going to be one of the major issues in the next decade or so. And you have already seen the evidence of it. Anyway, so these are the components of Industry 4.0. Now let's go to the main part of the presentation today, which is about digital manufacturing. Sorry, just one last slide I forgot to mention. So this is just telling you about different applications where Industry 4.0 technologies are used: medical services, retail, communications, but more importantly, in the manufacturing side, like industrial products, electronics, or automotive. Okay, so this is where most of the Industry 4.0 technology has first come. Okay, so going to the first topic of digital manufacturing with the Industry 4.0 technology. So transitioning to digital manufacturing with Industry 4.0 technology. The first thing we'll have to discuss is what is digital manufacturing. Again, digital manufacturing or digitization of manufacturing or smart manufacturing, these are all basically an application of computer systems to manufacturing services, supply chains, products, and processes. What that basically means is you link different systems and processes across all areas of production to create an integrated approach to manufacturing. Okay, so that's what the whole idea of the digital manufacturing is all about. Now, the question is, how does it vary, or why there is a need for a digital manufacturing, and how does that differ from the traditional form of manufacturing? So compared to the traditional manufacturing, where Yeah, the idea is compared to that, the traditional digital manufacturing is a more integrated system. So let's say, as I mentioned before, whether it's the design process or its actual production, manufacturing, or distribution, again, these are all connected in an integrated process or as part of an integrated system in a digital manufacturing. So how does that help? So in a traditional manufacturing, if you wanted to do customization, it would be very difficult because you have less control over the operation. Here, in the integrated process, if you want to do customization, you have more control over the design process and you can make sudden decisions or more quicker decisions. Let's say, as I mentioned with the 3D printing, you want to try something new. You can try with the 3D printing a new prototype, and that decision making of changes or customization or more flexibility comes earlier in the manufacturing process, in the design phase. This is where the digital manufacturing differs from the traditional manufacturing. Okay, hopefully you understood that. In that case, the question is the digital manufacturing timeline. So how does that actually come about? Similar to the Industry 4.0, by the way, you can see at the left top side, there is a zoom in and zoom out button. So that's individual for everyone. So if you find the slide is a bit hard to follow, you can just zoom in and you will be able to read it a bit better. Not each slide is at the same resolution. Anyway, so when we're talking about the digital manufacturing and the history of digital manufacturing, you will see that with context to Industry 4.0, how that comes about. The term smart manufacturing basically came about 15 years ago, but this was more explained better when the term of Industry 4.0 roadmap was created. With that, in the last 5 years, you'll see there has been more fixed definition of what smart manufacturing or digital manufacturing is, what are the policies related to it, what are the scope that falls within smart manufacturing, and different countries, for example, US, Singapore being some of the big leaders in manufacturing, and even the Germans, yeah, you can see they have their own institutes for developing more Industry 4.0 technologies that leads to smart manufacturing, or as I mentioned in this, for the context of this webinar, it's called digital manufacturing. So if we put everything into context, and again, I won't run the same thing too many times because we have already given you a few examples, but the whole point of the digital manufacturing is it's across all platforms, right? It's in the product life cycle. So starting from the design, production, manufacturing, all the way to the distribution side. It's also part of the smart factory. So in the operations of it, the different machines that are operating together, that's where that's also falls within the scope of digital manufacturing. And most importantly, or rather something that doesn't get mentioned that often, in the value chain management as well. That's also part of digital manufacturing. So the value chain management actually focuses on reducing the resources to create a more optimal process so that you use less inventories, for example, while maintaining the product quality and customer satisfaction. So everything actually from the design all the way to the delivery falls within the part of digital manufacturing. And this is basically what's explained here in a more elaborate fashion, whether it's the early stage where you are doing a new product design, or how you're going to define that project with, let's say you have your 3D printings, your CAD models that you're using, or in the actual manufacturing process. Here you are doing manufacturing simulations like digital twin someone else was mentioning about, or about the production part, the supply chain analytics, like how to improve the operation, or the field area diagnostics, like how the machine is actually operating, how the product has actually come about, whether the customer satisfaction is. Also, those are all things that are taken into consideration. So all of this actually from the design all the way to the delivery falls within the part of the digital manufacturing. Okay. Now, we will go to the actual components that make digital manufacturing in a minute. But before that, I'll just quickly go through the advantages as well. So, of course, I already mentioned the process optimization. So if you know where each of the machines are operating and how they're operating and which efficiency they're operating, you can make changes to make it more efficient, because you have the holistic view and you have a you have a better overview of the whole operation, and you can see where the changes can be made. That will increase the efficiency because the errors will be eliminated. The products will be coming around faster. You'll have much more real-time manufacturing visibility. So that's why something that digital twin offers as well. Something that if you, in the real time, you can see if the operation runs is in this way, can we make the changes or not? And similarly, the whole smooth design process becomes smoother, and you have reconfigurable production lines. So any changes you want to do, there is more option. For example, if you do cloud manufacturing, so the cloud operations can be changed in order to make the operation more efficient. So everything gets a bit more efficient with the digital manufacturing. Some very simple data that will make sense for you guys, how the digital transformation is happening with the US market, for example. There is a trend, increasing trend with solutions as well as the services that are being provided. Even if you look at the numbers, like with what digital manufacturing does, reduction in maintenance costs, productivity increases. Also, you can see costs are decreasing in as well, and you can see forecasting accuracy, like when predicting maintenance, that actually improves as well. I'm sorry, I'm running a bit faster with some of these machine slides because just to meet the time requirement. Now, so talking about this digital manufacturing, now what are these Industry 4.0 technologies that is causing the digital manufacturing to be successful, basically? So if you look from the current trends, and this is more from the business point of view, right? So you can see things, some of the, so we'll focus a bit more on the engineering side, but technologies such as predictive analytics, big data, predictive maintenance, AR, VR, lean manufacturing. So these are basically the aspect of engineering that digital manufacturing is providing. So our question now at this point is, how is this happening and what technologies are making it happen? So let's go through some of the Industry 4.0 technologies that is key part of digital manufacturing. So the first one, of course, we already mentioned was cloud computing. So with cloud computing, as I mentioned before, cloud provides you two things. It provides you storage, so you can store a huge volume of data that's coming, but also it can provide you analytical support. So this huge volume of data, because the cloud servers would be so much faster, so you can collect those data and do the calculation and send the information back to the machines to make the decisions accordingly. This makes the process so much more efficient. And to be honest, all the technology that we're going to discuss a bit later on, they're all interconnected. So for example, we're talking about predictive maintenance in the previous slide. For example, this one, or predictive analytics. How does that happen? That happens with the help of artificial intelligence, but that is hosted by cloud computing. So cloud computing allows this to happen. 3D printing, we already mentioned before. With 3D printing, designers can get their prototypes produced locally and immediately without having to go through a more longer process. And those prototypes can be easily modified, which allows designers to, let's say, take more risks. And there is better opportunity, even if they make mistakes, it's early on in the design process, and the cost or the delays in production won't be that much. That flexibility is allowed by digital manufacturing. Digital twin, someone was mentioning about. So what is a digital twin? A digital twin is a virtual, yes, 4D printing is also establishing, isn't it? So it's moving fast. So a digital twin is a virtual representation right? That serves as the real-time digital counterpart of a physical object or a process. So let's say the same physical process that's happening in the physical system, you run a virtual representation of that in a basically virtual system. So that's the digital twin. So a physical system is running, and the data from the sensors are being fed to that software where the virtual system is running, and the virtual system is running at the same data as the physical system. How does that help? It helps if you want to, let's say, monitor a certain product or a process, right? If the operation is running in parallel, let's say you want to make a certain change to the operation. I want to change a couple of the parameters to see how the output would be. Instead of doing that in the practical system and risk damaging it or risk delaying the operation, and then what happens is in the digital twin, you can actually make the changes to the system, and the output will actually be coming on that there. So that based on that results, you can get an idea of whether the system actually can be transitioned to that idea. I'll show you a couple of examples of how different companies actually do it at the end of the presentation. So that might help some of your questions about actual softwares or actual techniques digital twins are actually used in. But again, similar to the digital twin of all the previous technologies that we have been presenting, right? All these technologies like digital twin or whether it's cloud computing, they're all connected with each other. Even the digital twin relies on the sensors providing the data, and then data being mined, and that artificial intelligence providing information based on that. AR, VR, it's one of the more like hot topics, we can say. So again, idea with the virtual reality is virtualization of a certain process or a certain system, and augmented reality is when you actually have a real system and you can add or enhance to it with augmentation. Now, there would be a different argument as, for example, why do you need a virtual reality if you already have a digital twin? How does virtual reality and digital twin differ from each other? But that's a completely different argument. We can't really go into that, but we can say that the digital twin is for real-time systems. But yeah, so there is a big discussion for that. But anyway, so with the AR and VR, some of the examples that you can do, for example, inventory management, right? So of course you have artificial intelligent algorithms that can streamline different processes, but let's say you actually, the augmented reality technology, what it can do is, for example, you have to, an employee needs to pick a task from a, you have a task of picking up a product from a warehouse shelf, right? That still involves manual labor. Now, if you use AR technology or augmented reality technology, it can help eliminate the confusion and make the process quicker. So for example, you can hold like an iPad or like wear like one of those Microsoft HoloLens that they have, those headsets, and they can give you instructions about the exact location of a particular item, and you can be guided through that. Again, technologies such as this, like companies like DHL, SAP are taking full advantage of AR enhanced inventory management. Similarly, VR can also predict as well, and they can, you can evade different disruptions or risks in an assembly line operation using VR technology, because they're simulating the production environment, and they can, predict or indicate some potential threats or some weak points in certain machinery, and you can, eradicate or you can get out of those scenarios. Okay, I think we already did digital one, and also we'll mention a little bit about big data and AI as well. So again, with big data and AI, machine learning technologies being used to do as well. Someone asked what AR is, right? So AR is augmented reality. So again, I think I just mentioned at the beginning as well. So augmented reality is basically an an interactive experience with a real world simulation. So the object is actually in the real world, but using a, let's say, a machine like a computer, they're preparing or they're enhancing that perceptual information. So let's say you have a machine here, right? So let's say this machine is in real system, right? You are looking through a tab that's providing you with the AR technology, and you can see the perception of different parts of the machine internally, and you can make certain changes on the tab that is actually providing the actual data from the system here. So that's what augmented reality is. Virtual reality is much more simpler. Virtual reality is a virtual simulation of it's basically a computer generated simulation where a person can interact within like three-dimensional environment using an electronic device. So using those VR headset, you can go into a space where you can see the 3D environment that has been created, which is a simulation of an actual system. Okay. We won't have time to go through much of the challenges, but just to summarize what are the different challenges. So of course, this is quite clear that this transition needs to happen. And I saw someone saying, what are the different job prospects there as well? There are quite a lot of job prospects. So especially with the way industry is going, the more trend in the next decade will be about people having technology expertise, whether it's AR, VR, whether it's digital twin, and the operation will move from manual labor to more higher level monitoring operation. So there will be a more emphasis on learning these softwares to learn to operate this. Cybersecurity, right? Part of Industry 4.0. You do cybersecurity, you have cybersecurity expertise, there is almost a guarantee that you will get a job in a couple of years within different industries, because every industry is trying to move to that. Anyway, going back to the point, the main issue with the transition to these technologies are integration challenges, right? So when these different machines are communicating with each other, how do you integrate them together? So that actually requires a good understanding, a good knowledge base that's not there. That's why, you know, everyone who's interested here, I would say, is already ahead of the curve, because you are already aware of it and trying to make the next move. Also, you need more investment and moving away from the whole, you know, old techniques to more the new technique. And that's what the companies needs to do as well. So the main thing would be start small, identify a couple of key technologies that you can use. You don't have to do everything. Just try, let's say, implementing the cloud computing. First, try that and upskill your talent, you know, the employees to that. Do some investments, and it will slowly happen. Now, going to the last part of the presentation, and I'll probably have to hurry through a little bit. I'm sorry, Riley, for the delay. So some of the use cases of how digital manufacturing is going on, right? So let's see. ABB, I think you have, or probably all have heard about what ABB stands for, right? The presentation will end in the next 5 to 7 minutes, yeah. So, so the company's collaborative robotics, as you can see, is designed to work alongside humans in the manufacturing process. So you can see the machines and humans are operating together as well. So these are more collaborative robots. They are designed in a way that is safe for humans to be part of the operation. You also have concept of predictive maintenance. That will be a common theme. So that's one of the main things when you are doing it. So what are the cost implications in the developing countries? Okay, I'll explain that at the end of the session. Okay, so Airbus. So the next one is the Airbus, again, the European multinational aerospace corporation. They have the digital manufacturing initiative as well. So they have actually sensors that are on the shop floor. So actually on the operating floor, they have sensors embedded, and they have workers with wearable technology that is designed to reduce errors. So again, these sensors are not only connected to robots, but also humans. And those feedbacks are being collected and analyzed to produce, suggest where the errors can be happening. And you can see a 500% improvement in productivity. Siemens also, you can see that I'll just give one example. When the work begins for one of the days, the digital twin determines the most efficient way to operate the entire factory and manufacture each product based on all the tasks at hand. So imagine you have a whole factory of hundreds of employees and machines that are working, and it's the digital twin technology that's making, based on the data, making real-time decisions of what is the best way. Let's do A first, then C, then B. If we move in this process, the operation will have the most optimized output. Again, a very simple example of how manufacturing is enhanced with these technologies. KUKA, again, again a robotics operation, right? So German robotics specialist, they have an IoT-enabled factory. They have hundreds of robots, and they can produce almost 800 vehicles a day. Again, IoT-enabled factory means robots communicating with each other. Humans don't have to be present for every part of the manual labor. Rather, they can operate even from a remote location. And I think we all know nowadays how working from home or remote working is a blessing. In some cases, of course, not everywhere. So yeah, also things like you have companies like Bosch as well. You know, they have embedding sensors fit into their machines, and they use data analytics tools. So once this data is collected about the different machine conditions, they analyze it, and you can see there is an increase in output of one of the parts, which was the automatic braking system and the stability program. So these are actual data. You can see the link here. So these are actual data that is providing to see how it was successful. Also, like laser machines, they also have machines working together, Trump being one of them. Ford, again, they have, this is the one I was trying to tell you about. Ford have a factory of the future, and they produce 7 digital twins of each model of vehicle they produce. So they produce one vehicle and they produce 7 different digital twins. So 7 virtualized models, and in each model they will do something different to see how the same model could operate with slight tweaks to all of them. That gives you an idea about how each of the systems will operate and which one will be the most effective. And of course, they're trying to move from low resolution to high resolution, so more effective and more actual accuracy. So these are examples of all these different technologies that we mentioned that can actually be used in different parts. So in summary, I'll just quickly mention that it's, I think, trying to embrace, all the technologies of Industry 4.0 and drive towards a more digital manufacturing process. It has lots of different parts, and the main thing will, it's all be integrated. So you can, pick one part that you are interested in. Even EIT has lots of courses in many of these topics. Feel free to contact us, and we'll be happy to provide you more info. So that was all today. Just a quick introduction on Industry 4.0, a little idea about digital manufacturing and how that relates to Industry 4.0 technologies and use cases. I saw one question about Industry 5.0. Interestingly, last year's presentation was about Industry 4.5.0. Abhishek, if you just send me an email, I can send you that presentation link as well. But with Industry 5.0, the main idea will be bringing humans back into the operation flow, right? So with Industry 4.0, the idea is all machines are working together. But with Industry 5.0, so there will be 2 parts. One is bringing humans back to the operation flow, and the robots, instead of being autonomous, they will be more collaborative robots, like the one we saw with ABB. So humans will be working alongside. And the other part will be, there will be a more sustainability aspect. So we'll try to reduce the waste of these different manufacturing operations so that the operation is more recycling, more greener, basically. And one other question I think I saw somewhere was how to think about this for the developing countries, right? Cost implications. So I think that's where the developing countries will have to start small with smaller technologies. But to be honest, a lot of this technology that we have mentioned, some of them are quite small technologies that can actually be implemented. But with the bigger, like developed countries, they have already invested. With the developing countries, it will be slow, but the idea will be to start with 1 or 2 small technologies, and they can do that. I know I'm from Bangladesh, and I've seen, like, green technology a lot being used in different parts as well. So you can, use your surroundings. So that's it from my side. Riley, maybe you want to quickly mention about the upcoming webinars?
Thanks, AK. Thank you very much for the informative presentation. That was great, and I think everyone really appreciated that. I'd like everyone to know that we have an upcoming webinar next month on our online labs. So if you want to have an insight into our online labs that are used in our courses, you might want to have a look at our events page on our website for that one. And we are scheduling some technical topic webinars for next month. So please check our events page regularly for that. Also, as mentioned, we do provide a free certificate of attendance for our technical topic webinars. So I will provide the link in the chat box, or if you have your phone, maybe you can scan the QR code there. That will also take you to the form. So we've changed it up slightly. So you'll need to just fill out your first name, last name, email, and then there'll be a short survey of this webinar. And once you submit that, we'll send a certificate of attendance out to you within the next 3 business days. So we'll be in contact with you once you've submitted your form, and I'll just post the link in the chat box again there, or please scan the QR code. Now I know Dr. AK has to go teach a class now, so unfortunately he doesn't have much time left. But if you do have any questions for me that maybe I could answer for you, please post a question in the chat box. If you have any non-academic questions, you can find all of our contact details there on the screen if you want to go to our website, or if you would like to give us a call, or if you'd like to send us an email about our webinar, or if you'd like to get in contact with us, please feel free to send an email. So thank you very much, everyone. Thank you for joining today's session. We really appreciate it. We hope to see you all next time. Have a great rest of your day wherever you are. I will stay in the session if anyone has any questions for me, and I'll stay on for a few minutes. Thank you. Hi, Rhino. We do have some PLC courses. I would encourage you to have a look at our website. We do have a professional certificate of competency in PLCs and SCADA, so I'd encourage you to have a look at that. But if you're looking for an accredited course, you would be looking at one of our industrial automation courses. So we have an advanced diploma of industrial automation, and also courses in the higher education sector, such as bachelor's and graduate certificates and master's degrees. I'll just provide the link for the certificate of attendance again in the chat box. in case any of you missed it. If you need to leave, feel free to do so. I'm just sticking around for a few minutes if anyone has any further questions. Hi, Pravu. I appreciate your question, but unfortunately, I won't be able to answer any technical academic questions, but I would encourage you to have a look at our website or send us an email if you do have a technical question, and I can refer this on to Dr. AK. Thank you. Isera, the course on PLC, I think the one I mentioned, the Professional Certificate of Competency, it's not a free course. It's a short 3-month professional development course. Our professional certificates are non-accredited, but if you are seeking a qualification, we have a range of accredited courses. Hi, Landry. It is possible to watch this presentation later. So in the next 2 business days, we'll send an email with the PDF slides and the link to the video recording of this webinar. Thank you. Hi, Hubert. There is not a upcoming webinar on SCADA systems at the moment, but I will note this down and pass this on to the team. Thank you. Hi, Ronald. So I can get one of our course advisors to get in contact with you after the session if you would like, and we can send through some information on our range of engineering courses, including the time, duration, and fees. You can also look on our website EIT.edu.au. We have a dedicated page for our fees, which you can see all of our course fees once you put in your country of residence. But otherwise, you can browse all of our courses on our website. Thank you.